So I'm back with yet another project here. Unfortunately, I'm having to dub this entire beginning section over because I unintentionally forgot to unmute my mic during this. This is a DeWald A-503. It's an AA5 set, and I was requested by someone local here to have it bring it back to working condition. And it was in the family for a while. They wanted to get it running, and so I offered to help. So one of the things I'm actually pointing out right here is I talked to the owner about having it refinished, but during my initial inspection I noticed the two squares, the left and right of the dial, are actually photo finish. And you can see that because I'm pointing at two sections that are actually chipped away, and you can see the base wood underneath. Normally if this was a veneer, it would have a much deeper difference in depth. So you'd have a thin layer of veneer, maybe 3/16 of an inch thick, and then you'd have a substrate below that. And in this case, it's paper thin, and then below that you basically have a very soft wood. So if I was to strip this thing, although I could get the decal for it, for the DeWald bit, I would never be able to replace those photo finish pieces, sadly. And I've already completed the set, and the owner and I basically decided that we're going to leave the set as it is. There was some warp damage on the top there. In fact, the whole back end is starting to curl up, probably from humidity and the fact that they stated that it was on a workbench in the garage for a good chunk of its life. So this thing it's seen some wear and tear. Interestingly, in my research of these sets, the DeWald logo and all the ones I've seen online, it was almost always in the dial itself and not a separately applied decal. This is the only one I found pictures that I know of that has the decal on the front grille rather than being etched into the glass on the back. So I'm going to go ahead and tear this thing down just to get into the chassis because it's an AA5 and we can crack this thing in an hour. Now, a lot of the paper label did survive, although part of the tube diagram is missing. There's nothing special about this. It's your usual 35Z5, 50L6, blah, blah, blah. Usual AA5 tube setup, although one of the screws, actually the one I'm trying to get out, was a replacement, and it's got the wrong thread pitch. It's actually just a bit too coarse for the chassis, so I'm probably going to have to find an appropriate replacement at the hardware store in order to get that back. Yeah, that screwdriver is not going to work. Have to find something just a little bit more beefy for that. Yeah, it's a bit long, but it works. So this particular set does not have a backer on it. There were some staples at the top of the back of the cabinet, but there was no other indication that it actually had anything protecting the rear. The antenna is a typical wound style on a cardboard piece that's then screwed to the chassis. Oh look, there's the cabinet again. I don't remember what I was saying during this part. It must have been something incredibly important. Set it out of the way keep it out of harm's way. The dial pointer actually was kind of neat. Instead of just being like a solid piece of metal that was painted, it's actually made out of translucent red plastic. And I'd hoped that the dial light would actually light it up enough to make it glow, but testing later proved that that was pretty much a moot point, considering the single 47 dial lamp has no reflector or anything to cast a light even close to that direction, so it is kind of useless, other than to tell you that the rectifier is in fact firing up. So Typical packed layout. I did notice that the output transformer was either replaced or the factory just did not bother with getting one with very long leads because there is a solder splice in between the two, which was just a tad unusual. And then on the underside, there was evidence of relatively recent work, probably 1950s. The set was probably from the mid to late 40s, at best guess, still using octals. You can tell because the bracket holding that multi-section electrolytic in place is simply soldered to the point where the old bracket was cut off. And then the wires were just sort of lazily pressed against the terminals and soldered quickly enough to solidify them, which would have worked. Oh, and the line cord had been replaced. And the cord itself wasn't bad, but it was a non-polarized plug. And since the power switch on this connects to chassis, I wanted to make sure it was as safe as I could get it. So a new polarized power cord would be a necessity. The capacitor I just poked at actually is a .05 that goes from line to ground, so we're going to have to replace that with an X2 type safety cap. And I did wind up replacing the number 47 dial bulb, although the old one, the new one, had no difference in brightness and made no change in how bright the dial actually got, unfortunately. The other thing I'm pointing out here is that this set is still old enough that it uses the nice big style of intermediate frequency transformers that have fixed inductors and variable capacitors versus the later style that get silver mica disease that have a fixed capacitor on either side of the circuit and a pair of tunable slugs that have the possibility of either breaking off or just being an absolute pain to try to adjust. I haven't had any difficulty with that in the past, but having had to deal with silver mica disease, I can safely say that it is much easier to adjust these because, as I'm demonstrating, you can break the trimmer screws loose with a normal screwdriver, and then when you actually go to align the thing, you can just use a standard non-conductive, non-ferrous tool. I actually have a pair of spudgers, sort of like the ones you get from iFixit, I think, that have a flat blade at the end, roughly the right size of it, that I can use to tune those once they're out of the way. So repositioning the deal here. There's not a lot of capacitors in here. Most of them are .05s, the occasional .01. I think there was a .02 in there, a little bit different, but nothing super out of the ordinary. Like I'm pointing out there, we're going to replace the power cord with a new one. Okay, so in my infinite wisdom in the opening clip, I forgot to unmute my microphone. Not the best idea ever. Anyway, we're back with the DeWald, and I checked my part stock, and we have all the caps that I need to get this little guy put back together. So I am going to go ahead and just edit it to the next section where we'll have all the old caps removed and all the new in place, ready for a test run, hopefully. And just like that, we are ready to give it a try. We've got the two new electrolytics installed nicely. We've got heat shrunk leads going in through to that. I didn't have 230s. The replacement cap here is actually 240 microfarad units, but the schematic specified that he used 230s. And since I was down to just the one, what I did was I put the 30 microfarad cap on the actual rectifier so it charges up, puts a lot less strain on it, and then I put the 40 after the resistor of the little pi filter they set up so that it doesn't overload the 35Z5. I've got the new X2 safety cap set up. New polarized power cord is installed. So I'm going to fish my power cable over, and then we're going to give this a try here. Flip her around. There is a very small tear in the speaker cone that I'm going to have to take care of. It's hard to see. It's just, yeah, see. I have to gently patch that so it doesn't get any worse. And then we'll clean it up a little bit on the chassis side. I'll rotate it to the side so we can see the tubes fire up there. Alright. Pilot lamp fires up a little bit. The pilot light is actually hooked up to the rectifier filament, which is where it gets its 5 volts, so it uses the drop across that in order to power it. So you can see the rectifier tube filament is sucking most of the power out of the circuit, and once everything has gotten all the way up to power and its resistance has gone up high enough, and we get higher voltage for that little guy. And, oh, looks like we've got some noise. I've got a few too many things hooked up on the power supply here that can cause interference. So let me unplug those. Okay. Well, didn't really get rid of all the noise. We got rid of some of it.
Without having to open up my books to them. Down 13, three-quarter of 5, he hits. As he hits the deck, it's up quickly as they'll defend in the backcourt a 10-point game with 28 seconds to go. Will they extend the game with Powell? So far, Iowa State able to escape it. The Halliburton looks like...
I think on this one, this is the... No, this is the police end of the dial. The other end is the one. So yeah, we got the ESPN bit there.
Looks, but there are our top
local talk shows.
Starting these games in a row, he's starting to feel real comfortable, and it's really helping us.
Maybe that was ESPN. Don't quite remember.
That's a good point. Fan hands.
Well, that's about the same logic as man.
There's a good chance a good amount of this humming is actually coming from my fluorescent fixture here. Quite possibly. Let's see. Yeah.
Act being committed will save another person more than 1 million times a year to a government report from the night. Right, and that's
Win games like this, we just gotta lock in.
all right. Zach Collins and the Blazers getting ready to take on the Spurs tonight in San Antonio. It's time now to go inside the locker room with Casey Holdall of Trailblazers time.
Alright. Well, I'd say that's pretty good. I do want to do an RF alignment, or an IF alignment on it, actually, and get the two IF transformers peaked to where they can. This set may not get used all the time, but I do at least want it to work as well as it can when they do fire it up. So I'll pull out the signal gen here and a probe, and we'll see how that gets done. Alright, so getting set up to do the IF and RF alignment. We have some very basic instructions what would come in with the schematic in terms of doing the actual calibration. So the gist of it is you hook your signal generator up through a 0.1 microfarad cap to the chassis of the set to isolate it. Got your RF output. That is supposed to be connected to, it says it's supposed to be a flexible lead or something hooked up the antenna. There isn't anything there, so I'm just going to connect it to where I'm pretty sure the end of the antenna should be. It's actually got a 2-part loop on there. And then we're going to go ahead and fire this. Actually, we don't need, yeah, we want the audio attenuator. We want this. And then we're going to go ahead and fire that back up. And the last thing I need is a multimeter. Now, one of the ways to do this is with an oscilloscope and a detector probe and some other stuff to actually physically see the peak, but for that you really need a sweep generator, ideally. I don't have one here. So we are just going to be doing this the easy way, which is to set up this voltmeter here. And we're going to place it across the leads of the antenna. Or, sorry, the speaker, actually. Now that I think about it, probably should have done this before I turned the set on. That is the power of hindsight, after all. Anyway, got that hooked across the speaker now. Let's see, we can turn that up and we can get her high back. Alright, what we're going to have to do is turn this off so I can't hear it. Not getting the 455 kilocycle sound. Let me try something different. Ah, there's our noise. Alright. So according to the instructions, we want to set that there. Set this to where that's minimally hearable. So now we got it there. Now we need a non-conducting adjustment tool. You can't use anything ferrous because it'll alter the capacitance, because the screw itself actually makes up 1/2 of the trimmer or adjuster capacitor, and we're going to want to go from the end closest to the output, which is going to be this guy. And jam this in here carefully and twist to see where we get higher output. Alright, that sounds pretty loud. Then go to this one. And go back. Alright, that one's peaked pretty good. Turn this down a little bit. And then go up to the next one. Right about there. Turn it down a little bit more. Right about there. And then we go back and check this one again. Alright. Seems like we're pretty decently spot on with that. I'll go ahead and turn the attenuation down and disconnect this for just a second. And then we're going to make sure that we're still tuning in stations.
So, yeah, definitely pick up an umbrella policy once you... Being in the summer with guys that...
Alright, so that seems to be okay. Now the next step is, let's see what we got here. Open the variable tuning capacitor. Alright, so we got to crank this thing to where it's all the way open, which is going to be at the other end of the dial. When they say open it, they're referring to the meshing of the capacitor plates in the variable tuning capacitor here. So we're going to crank this until it's all the way open. Very, very, very slow process. Alright, it's all the way open. Now what? Let's see. Set signal generator at 1720 kilocycles. Really? That doesn't seem right. Part of my problem with this is that the dial scale, this end of the dial is 550, whereas this end of the dial is the police band 1700. Now, they are correct in saying that when you open the tuning capacitor all the way, and to set the signal generator at about 1720 kilocycles, yeah, when you open the capacitor all the way, the higher the that actually lowers the capacitance value. The capacitance increases as the surface area that it's directly in the two plates are directly in contact with each other. The higher the surface area that those two plates are in contact with, the higher the capacity. In this case, we have the absolute minimum capacity, so the oscillator section is running as fast as it possibly can. But the dial is at the wrong end, at least just based on the cabinet. You can see it says 55 at the end there, that is times 10. And we've got 1700 at the other. And these instructions do state for this model. So my guess is that whoever set this dial scale set it up backwards, effectively. So that's a little weird, but we'll know if that is in fact the way it's running by hooking up the signal generator here, flipping it over to where 1700 is, or should be on this machine, and then testing that. So we need band C. Turn this up a little bit. Let's see, we're not getting anything, which makes me wonder. Oh, hold up. Yeah. Okay, so they said 1720. Now the increments on this are 20, let's see, 10, 20, no, 20, 40, 60, 80. Yeah, so we want that one. That should be about 1720, give or take. And then it states we need to peak the oscillator section. The oscillator is going to be the smaller of the two adjustable caps. I'm going to have to go around here to get to that, because those are only accessible at the back of this. So we've got the large tuning section, and we've got the tiny tuning section. And the tiny one is for the local oscillator. So we're just going to give that a twist. To move a few things around here. Well, not hearing that test tone. It's not too comforting there. See, the problem is now it's a little bit lower. We want it to be up here. Let's turn up the volume a bit. There we are. That's our signal. So yeah, whoever assembled this set put the dial scale backwards, or honestly, I don't know. It was strung in reverse. It just doesn't make any sense. The way the tuning capacitor is set up, this is the 1700 cycle end, and that is the 550. And I'm pretty sure that I can confirm that, but they do say the next test we need to do is to set the signal gen. Let's see, peak oscillator section of receiver against maximum. Now set signal generator at 1500. Let's see. Yeah, some interesting constructions there. Set signal generator 1500. Tune in the signal. Adjust RS section of receiver variable. Fascinating. Well, we'll try and follow their instructions. So we'll go ahead and we'll set this to 1500. We'll back the dial off and we'll see if that is exactly where it should be. Alright. There's our tone. Oh, we weren't supposed to adjust this. This is supposed to remain in place. So 1500. And then we're supposed to fiddle with the standard RF section. Alright then. Except that I don't seem to be getting it anywhere on there, which is really annoying. Oh dear. You know what, we're going to go ahead and get the meter out of the line, because as it is, we're doing all of these adjustments by ear, simply because it's easier. Oh, I missed an important step. They did actually state that you're supposed to set this to 1500, tune this, wherever you find that, and then we crank the variable capacitor RF section. Okay, that's a little obnoxious. No change in audible output, but there may be a change in voltage. So we gotta set that back up. Okay, 0.177 there. See what happens when we give this a twist. .3, 0.185. Well, it is official. This trimmer capacitor right here is doing quite literally nothing. So I think it's fair to say we are just not going to even bother fiddling with that, because it doesn't seem to do anything. We're going to crank this down, disconnect that, and make sure that this still operates.
Manufacturer. Different. In fact, for the first time in a long time.
Well, I think that about does it for this. Still works. Dial's cable may be completely backwards, but that's not my fault, and there's nothing I can do to rectify that, because I can't just flip the glass around and call it a day. So, a little bit of a learning lesson. Sometimes manufacturers make big, stupid mistakes. Apparently. I'm guessing the tuning condenser should have been on the other side of the set. But the good news is, it works like a top, and I'm pretty sure the owner will be happy with the functionality. Go ahead and flood the area with blinding light again. this guy around. So the last thing to do on this chassis is just get the remainder of the dust off of it. I have to patch that little crack in the speaker and clean the chassis up, and this will be ready to go back in, and then I will discuss the possibility of doing a little bit of cleanup work on the cabinet with the owner. I can in fact get brand new reproduction decals for this, but as I said before, the fact that it uses faux finish here, photo finish actually, at those two spots is a bit concerning. I can easily do the rest of the trim work with toners. That is not a problem. I'll just pick the screws up later. But it's really is just those two pieces that make me worry, because if those get damaged, there is no getting them back, sadly. Photo finish isn't one of those things that gets reproduced by large companies. Some people have gotten pretty good at it by using computer software. I don't have the expertise to do that. And we're all back together. Got the dial glass nice and cleaned up for the most part. I went ahead, got the chassis cleaned up a little bit, and I also took care of some issues with the dial cord slipping. I had to add an extra turn onto the shaft of the tuning knob in order to actually get enough bite for it to properly move back and forth, and I cleaned and lubricated the bearing on the tuning condenser to deal with that. So again, I can't fix the issue with the dial scale being totally reversed, but the set still performs extremely well, picks up stations clearly without any external interference, and where this is going, I'm sure there won't be a lot of it. I'm not going to do anything to the cabinet unless the customer wants me to. They might just want to keep it the way it is, because it's a family heirloom, and it was sitting on a workbench from what I was told, so this might be exactly how they remembered it. Slightly battered, a little bit worn, weather beaten, but still totally functional, and hopefully it'll continue to be for at least another few decades. So that's all there is on this little DeWald A-503, and then as you can tell from the background there, it is time to start finishing up the Hoffman. Till next time.